Good afternoon, all. Welcome to another lecture of 8085 instruction sets, in which I hope we were studying the branching group of instructions. Yesterday we have seen the instruction sets which were used for the logical group, and today we are expecting to finish some of the branching instructions. Now these instructions are very important because we need to cut short the programs, right? So as I told you that in the first two programs in the list, we are having two arrays of 256, right? So we are having data which is stored in some of the memory location, right? Like 6030. So there is a 256 data, right? Now this data is supposed to be copied in the another memory location, say 6050, right? So what happens now? If you start copying this data, you'll require 256 and more instructions, and the program will be lengthy, right? To cut short this, what we will do is we will make one set of program, and in that set we will try to repeat that set in the same program, right? For that we require these sorts of branching instructions. So I will let you know how these branching instruction works. So we'll start with this. The branching instructions. The branching instructions alter the normal sequential flow of the main program. What it does, it just changes the data of the program counter. Right? Program counter, you might remember, program counter keeps the track of the program, right? So what this branching instruction does, it changes the data of the program counter so that the main program jumps to that location, right? And these are called as branching instructions. So they start branching it, like, so that is actually the concept of branching instructions. Now these instructions alter either conditionally or unconditionally. Means there might be a direct jump, right? Which we will use it when we want to make it in an infinite loop. We will use unconditional jump, or conditionally, or there might be some conditions like jump if not carry, means a carry flag is set or reset, other likewise. So we will see all those sorts of instructions. Now let me tell you what that exactly means. So if you are able to see my screen, I have shown you a simple program. I don't know what that program does, but I just need to tell you how the jumping instruction starts. So if you are able to see here, the memory address or the program which is written over here is starts from FF00, right? So this is the initial address of the program, and what it does is, now we have started the program, and if you are able to see here, JC, jump if carry, right? Increment A and jump if carry. So and we have to give this location FF0C. What it implies is this, if this instruction is executed, it will jump to this memory location FF0C, right? And we have to label something over here. So we can label here like delay, like your names or anything. So we can write there jump or forward or reverse or back. We can write over here, and that is what we are expected to write in the label column, like where we are supposed to jump. So in a main program, there might be more jumps. Like, so we are having some more jumps over here. If you are able to see FF1A, JZ, right? Jump if 0 and JC. So this, at this point, it is going to jump at this location FF23. So FF23, it's after this. So FF10, it is backwards. So here it is FF10, right? So this is back. So you have to write like that, a label where we are supposed to jump. So in a program, there are many jumps. I just need to show you this program. I don't know what this program does, right? So just to tell you how the jump instruction or the branching instruction works, to jump or to change the sequence of the program, right? So we'll start with those instructions. The first instruction of branching group is the jump. Now this jump instruction is unconditional, means whenever you use it, it will work without any condition. So it will go in a loop, right? So likewise, whenever we want that this jump instruction, like we have a program of clock. So I want that clock should go on running it, right? It should be in an infinite loop. So at the end, what I will do? I will just put a jump so that the main program will repeat again. And it will go on repeating again unless and until it is being stopped, right, by the user. So this is one of the instruction that we call it as a jump. And along with this, any of this instruction, we have to specify with the our memory location or the 16-bit address, right? So jump 2034, which implies that it will directly jump to this 2034 memory location, right? So this is one of the instruction which we might use, and these are some of the direct jump. So jump conditionally, J. Now the program sequence is transferred to the memory location specified by the 16-bit address given in operand based on the specified flag of the PSW. Now it is just written over here JX. Now JX, X stands for sum of the condition, right? Like here it is showing JZ. So we are having jump if 0, right? This instruction, the full form of this instruction is jump if 0. That's why that's how we have jump if not carry, jump if carry, right? Jump if parity, jump if odd parity, jump if even parity, like jump if 0, jump if not 0. Likewise, so depending on the flag's condition, we are going to jump. So this is called as a jump which is condition. Condition means there is some condition which is to be satisfied, then only this jump will work. Otherwise, it won't work, right? So jump if carry, jump if not carry. And here the example which is given over here is jump if 0, means whatever is the result of the arithmetic and logical operation. If it is 0, then this jump is going to be performed. If it is not 0, then this jump will not be executed, right? So this is the jump conditional. And then these are some of the instructions that I was talking about. So these are those jumps which we are given in this instruction. So JX. So X stands for these instructions. So there are various jumps, like jump if carry when carry flag is set, jump if not carry when carry flag is reset, jump if positive, that is the positive number, that is sign is 0, some jump if minus, that is if the sign flag is set, then jump if 0 if 0 flag is set, and jump if not 0 if 0 flag is reset, jump if parity is even when P is 1, parity flag is 1, and jump if parity is odd. So P equal to reset, right? So these are the status of those flags, and according to that, we are having these instructions, right? So just except auxiliary carry, we have all the flags which are being used in this conditional jumps, right? So whenever we have some condition to satisfy, then we are going to use this. So we are most probably going to use this jump if carry, jump if not carry, jump if 0, and jump if not 0. So these 4 instructions you just remember, and along with that, we have to specify the 16-bit address, right? So these are actually 3-byte instructions. 3-byte means one is opcode and the other 2 are the 16-bit address. So likewise, the next instruction, which is called as the call instruction. Now what it implies is, again, if we have a same set of instructions, like we have a program where a certain set of instructions are being repeated, likewise. So what we will do is, we will try to make another program. We will call that as a subroutine, and in the main program, we will try to call that subroutine, right? We call the other program which is situated at some other memory location. That particular small program is called as a subroutine, right? And in the main program, we can call that the subroutine program, right? And that for that we require this instruction. And here we have to specify the memory address where the subroutine program is being written, right? The first initial address of that subroutine. So this is a call instruction, which implies that we can call another program in between the main program, right? So the program sequence is directly transferred in the program counter. Now directly is loaded with that memory location where the subroutine program is being loaded. So that is called as a instruction, where we are going to call a subroutine program, right? Now this is a unconditional call, right? If there is no condition, direct call. And next one is conditional, return, means from the subroutine we have to again come back to our main program. So at the end of that subroutine we have to write this instruction, that is return, and this return is again unconditional, right? So in that subroutine we have to use that return instruction at the end of that subroutine program, है ना? तो वो प्रोग्राम के एंड में हमको ये रिटर्न वाला इंस्ट्रक्शन लिखना है, ताकि हम लोग फिर से वापस कहां पर आ सके, मेन प्रोग्राम में आ सके. So the program sequence is again transferred from the subroutine to the calling program. जहां से कॉल किया था वहां पर फिर से वही उसके बाद वाला जो कॉल वाला मेमोरी लोकेशन था, उसके बाद वाले मेमोरी लोकेशन में ऑटोमेटिकली वो रिटर्न हो जाता है, राइट? सो दिस इज ओनली अ 1 byte instruction. So example is simple RET. The next one is control instructions. Now these instructions which are actually, so only these instructions are branching instructions. So you might have understood. So branching instruction actually consists of some of the jumps which are unconditional, which are conditional jumps, and then these are some of the conditional jumps that we are going to use. And another branching instructions are call instructions. We are going to call and we are going to return that. So call instructions are also conditional and unconditional as well. So control instruction, now these are control group which are specifically used for some general purposes, like no op, means there should be a no operation. Nothing is going to do that microprocessor. The microprocessor is going to do nothing by executing this instruction. Matlab, we are just want to spare some time. So time pass करने के लिए हम लोग वो छोटा सा एक नो ऑप का इंस्ट्रक्शन दे सकते हैं. हम चाहते हैं कि कुछ देर वो डिले करे, है ना? तो डिले का एक प्रोग्राम होता है, एक पर्टिकुलर इसका उतने देर के लिए, दैट इज कॉल्ड एज नो ऑप और नो ऑपरेशन. Then the halt instruction, we have already used this halt, which finishes the main program, right? Which stops processing the main program. So that is called as the halt. Now what it actually does is, an interrupt or reset is necessary to exit from the halt state. तो एक halt state से बाहर निकलने के लिए हमको क्या करना पड़ता है? Escape या interrupt प्रेस करना पड़ता है, ये. So these are control instructions. Now disable interrupt, this is again a control instruction. I hope you won't be able to using these instructions in our program, but still they are listed in the program, so we are trying to understand what those mean. So DI stands for disable interrupt. Then these no flags are affected, and enable interrupt is there. Control instruction enable interrupt, and then we are having some summary. So these are some of the control instructions. Even input output and those instructions are being used for this. So I hope you have got this, what I need to tell you by branching instructions. So yes, we just can recall those instructions, and then we will sum up all the instructions that we have studied up till now. So today we have tried to understand what are those branching instructions. Like, so the first branching, what branching instructions are? These instructions actually alter the normal sequential program to another program, right? To another memory location, so that they might start from that program, right? So these are branching instructions. These instructions alter either unconditionally or conditionally, as I've told you. So this is one of the examples which I have loaded in this presentation, which actually shows where we are going to use these instructions and where they are jumping. So we have to show the arrow in the flowchart, so that we should understand that the jump is from here to here, right? So we will be using a kite sort of shape for these jump instructions. You might go through the notes where we can see how the jumps are being drawn in that flowchart. So jump, so we have to specify the address where this jump is there. So increment A, if there is carry, then jump from jump to FF0C. So FF0C is over here. So we have to jump from this memory location to this memory location, right? So this is how the jump actually works, and that's why they are being called as branching instructions. So they branch from one point to the other. So that is why these instructions are useful, and we might use many jump instructions in a particular main program itself. So branching instruction contains this. First is jump, which is called as the unconditional jump. Unconditional jump means there is no condition, but still the jump will be being executed. So simple jump is there, where we want that a program should run in infinite loop, right? So we'll be using this instruction. This is jump, and along with that, we have to specify the address, 16-bit address where we are expecting to jump over there. So jump 2034. So this instruction, if executed, the program counter will go to 2034 memory location. And while writing, we always write like the lower order address bus and then higher order address bus. So 34 and 20, like we have written in LXIH and the other instructions. So the another instructions is conditional jump JX. X stands for the condition that we have to satisfy, and only the jump will occur, otherwise it won't be executed. So this is over there. The program sequence is transferred to the memory location specified by the 16-bit address given in the operand based on the specific flag of the PSW. Program status word. ये जो flags है, इनके conditions पर ये jumps होती है. जैसे यहाँ पर एक एग्जांपल दिया हुआ है JZ, इसका फुल फॉर्म है jump it's 0. If the result of some arithmetic and logical operation is 0 or the 0 flag is set, then the program counter will have to jump on this memory location, that is 2034, right? So the other instructions which are included in this conditional jumps are JC, that is jump if carry, which implies that carry flag is set. Jump if not carry implies that carry flag is reset. Jump if positive, that is sign flag is 0. Jump if minus, that is sign flag is set. Jump if 0, that is 0 flag is set. And jump if not 0, that is jump J carry 0 flag is reset. Jump if parity even, that is jump if parity is even, that is P equal to set, and jump if parity is odd, that is P equal to 0, right? So this is conditional jump. Then we are having other branching instructions like call. I have told you that sometimes you have to use some small programs which are supposed to repeat in the main program after equal intervals. So what we will do, we will call those programs in between the main program, right? So we can use this call instruction directly in the program. These are unconditional calls, so this can be used. So after executing, what we will have to go with, after executing this instruction, the program is supposed to shift in that particular memory location where the subroutine is being written. Subroutine is a small program which is written somewhere else, and which we need to call in the main program, right? So these are the call instructions, and after executing this whole subroutine program, at the end of that, we have to write return instruction, right? So return means the subroutine is ended and we have to return to the main program, right? So again, after the call instruction, whatever will be the memory location that is being retained, and after return instruction, it will again come back to the main program, right? So I will show you somewhere when we'll be using those programs in the list. So these are branching instructions. Then some of the control instructions are no op, that is no operation, NOP, which implies that the microprocessor does not do any work in this instruction, but some of the T states are being used so that there might be some delay, so that they are used for those purposes. Then this is halt instruction. We have already used this halt instruction. and this is disable interrupt. So interrupt is disabled by this instruction. Then enable interrupt. The interrupts are being enabled by using this instruction, right? Like trap and all. So these are, now let us summarize what we have studied in all the instructions. So first we have studied the data transfer instructions like this: move MVI, move immediate, load accumulator directly from memory, store accumulator directly in memory, then LHLD, load HL registers directly from memory, SHLD, store HL registers directly in memory. So these are some of the data transfer instructions. Some more are like where X stands, means X implies for the register pairs, right? So LXIH, that is load immediate, the pair, register pair. LDA, load accumulator from address in register pair. Then stack, store accumulator in address in register pair. Then exchange, that is what we are going to use in the copy program, that the first program which we are supposed to construct in the next Monday. Hopefully some of the students may try that program. Exchange means the data between the HL pair and the register pair are being exchanged. Then we have XTHL, exchange top of stack with HL. So that we might not use. So these are some of the data transfer instructions. Then arithmetic group, that is sort of add, subtract, increment, decrement data in registers or memory. So add accumulator, add immediate data to the accumulator, ADC, add accumulator using carry. And one of the main important thing in this instructions are one of the data by default should be in the accumulator, and the other data that is to be added to the accumulator itself. So ACI, subtract from accumulator, subtract immediate, SBI, SUI, SBB, subtract from accumulator using borrow, subtract immediate from accumulator using borrow. Then increment specified by 1, decrement registers. INR stands for increment registers, the content of register. DCR stands for decrement the contents of register. INX stands for increment the content of register pair. And similarly, we are having DCX. I mean, DCX means decrement the content of register pair, right, by 1. And then we have DAD, double register add, means what you have to do, 16-bit addition is performed by this instruction. So add content of register pair to HL. So one of the data should be in register pair DC or in register pair DE, right? And that data is supposed to be added with the register pair HL. So in that is the instruction that, right? I hope there is one program which says that perform a 16-bit addition without using the DAD instruction, right? So we might use this instruction also. Then we have started with a logical group of instructions. Now these groups contains basically ANDing operations, logical Boolean operations on data in registers and memory, and on condition flags. So these instructions enable you to set specific bits in accumulator on or off. Then we have studied AND with accumulator and immediate with the accumulator, or the data of the accumulator with register, or logical immediate. This is actually ORI, right? ORI. So or immediate data. Then XOR the accumulator with the content of register, XRI, exclusive or using immediate data. And again, some more are compare immediate, then rotate, RLC, RRC, RAL, RAR, through carry and without carry. Then complement, so complement accumulator, then complement carry flag, and set carry flag likewise. So branch instructions we have studied: jump, call, return. These are unconditional branching instructions. Then conditional we are having not zero, zero, no carry, carry, parity odd, parity even, plus, minus. Similarly we are having yes, I hope we have landed somewhere else. Yes. somewhere we might have some unconditional calls also, conditional calls also. So we might go through that. Then we have conditional branching instructions, and then stack, push, pop, XTHL, extend stack, then SPHL, move stack, input output instructions. Initiate input operation means we have to input the data from the outside output devices to the accumulator. Then out data, we have to move the data from the accumulator to the output devices. That can be done. And machine control instructions, some of the enable interrupt system, disable interrupt system, halt, no operation, like this. So these are all the instructions that we are studied through last, and I hope these instructions will definitely going to help you in say designing some of the programs which we will be starting from next Monday, hopefully, or next class. So first program we will try to do is to copy and extend. So both the programs we will try to do. I expect from your side that if you have any queries or if you have any problems, just come out and give us a feedback so that we will try to rectify. And I again request on that note that since we have completed all the instructions, I have uploaded all those videos on the YouTube. So go through those videos. If you have any difficulties, learn those. Even if you have some apps, there also you can search some instructions and you can learn those instructions whenever you require them to use. Right. So I expect from your side that you will try to write some of the programs which you might understand. Just go through that. Even if you are not able to do, you might understand something, right? So I expect from your side, because we have to do around 20 to 26 programs in all, and we'll be definitely completing those since we are working in offline condition. So we have ample of time to complete those programs. So I request you all to kindly go through the list of the programs which I have already uploaded on the group, and try to write those programs. From next time, I hope, I expect from your side that you will be attending these classes by writing these questions on your notebooks, and will be trying to upload, write those programs for you. And we'll also try to execute those programs in the classes itself, right? So now let me stop sharing my screen. And yes, so I hope you have enjoyed these classes of instructions of 8085. We have today ended all the instructions, hopefully. And if some instructions are not being understood, I request you all that be patient. And while writing some of the programs, we might actually work on those instructions so that we will able to understand in depth those instructions. So right. Yes, let me thanks to all the participants which have attended this class and which have viewed this on my YouTube channel. Thank you very much. I will end this class, and I expect from your side that you will pay attention from the next class, because we are going to start programming, basic programming. So first we will start with some of the data transfer programs, and then we will continue with other programs also. So thank you very much, one and all, for listening and viewing my video. Thank you. Have a nice time. Stay safe, stay home, and take care. Good day. Bye. See you soon.